Hello everyone, this is Mrs. Ramsden and I am here to talk to you today a little bit about scientific notation. So when we are working with values that are really big or really small, sometimes it's easier to write them in kind of a shorthand way so that we can interpret and understand the values more easily. And it makes it less likely that we'll make mistakes relative to those values, like missing a zero. So we use scientific notation to write really big numbers or really small numbers. So kind of our value of choice, if it is bigger than 1,000, we hit the button. Pen tool. Or if it is less than 1,000th, those are the times when we could choose to report the number in scientific notation. So this will come up for measurements or values that you work with in class. So let's say that I wanted to convert 5,000 to scientific notation. There's a few rules that we need to follow. The first thing is I need to have one non-zero digit left of the decimal place. So that would put it in the ones place. So that means I need to put the decimal point right after the 5. I then need to determine how many positions I had to move the decimal to get it there, and it was 1, 2, 3. What that will then become is the power on the exponent of 10, because moving the decimal place is multiplying or dividing by 10. So when I have a very large number, I'm going to have a positive exponent, because when I multiply times a positive exponent of 10, that's going to give me a large number. So this as a calculation, if you would type this in your calculator, you would get 5,000. When we write it like this in scientific notation, though, it is not actually a calculation, it is a value or a single number. Now let's say we are looking at our negative exponents related to numbers smaller than 1. So I'd still need to put the decimal place to the right of the 5 to have my single non-zero digit in the ones place. And this time I had to move the decimal also 3 positions, but the other way. So here I would have 5, but because it's a number less than 1, I need a negative exponent. Same thing, if I would type 5 times 10 to the negative third in the calculator, I would get 0.005. So small numbers less than 1 get negative exponents when we convert, and large numbers are going to have positive exponents bigger than 1. So how could we summarize some of these rules and double check if our values are accurate? Well, first we said the reason we do it is because it's a more simplified way to report large and small numbers. Key rules, 1 digit in the ones place, and I multiply by a power of 10 that will get me to the value that I'm representing. Examples. 1.45 times 10 to the third. Notice we have a positive exponent. That's an indication that it is a number larger than 1. So moving the decimal point 3 times would give me 1,450. Here we have a very large exponent, 10 to the 23rd. That means the decimal place is 23 positions to the right from this position here next to the 6. This is actually a very important chemistry number that we will be learning more about in the near future, but we don't have to use very much quite yet. But I would rather write 6.02 times 10 to the 23rd than be counting out all those zeros. Here we see the negative 5, which is an indication that we're dealing with a decimal. Notice it's 1, 2, 3, 4, 5 positions to put the decimal where it is in the scientific notation. So if I'm converting a negative, I need to move so that I get a decimal. If I'm converting a positive, I have a number larger than 1, I move it to the right. Now, what is not scientific notation? Well, here, notice there are 2 digits left of the decimal. So that's a big no-no. I can only have 1 non-zero digit left of the decimal. Here, I have 0 in the ones place. That's a problem. I have to have a non-zero digit. So these are examples that would not actually be correct scientific notation. They're calculations and they might represent a real number, but they're not scientific notation. One last non-example I would like to add in would be something like 3.5 times 12 to the third. I can never have any power of something other than 10 because that's a different calculation and I'm no longer just moving decimal places around. So this also would be a non-example because it is not base 10. So practice some conversions here. This is going to have a positive exponent because it is bigger than 1. Positive exponent. So how many to move it? I need that decimal place right here to make the 1, that non-zero left of the decimal. That's 1, 2, 3, 4 positions. So this would be 1.45 times 10 to the fourth. Notice that I left off those placeholder zeros. I don't need them once I convert to scientific notation. Here, this number is less than 1, so I'm going to have a negative exponent. This is where I would want to put the decimal because that gives me my 1 in the ones place, and it is 1, 2, 3 positions away. So I have 1.57 times 10 to the negative third. Okay, last example. We have a big number, so this would be a positive exponent. This next to the 3 here is where I need my decimal. It is 1, 2, 3, 4, 5, 6, 7, 8 positions away. So my answer would be 3.04 times 10 to the 8th. This last section has some practice problems that you should complete, and I'll be building a few of them into the Edpuzzle so that you can get some immediate feedback on if you've done them correctly. Once you've completed the Edpuzzle connections, make sure that you go onto Canvas and do the additional practice to do some conversions between standard and scientific notation.